Hey everyone. All right, we're back. Um, so I need to do a lot of things. I'm preparing for an interview, data science interview. So the next hour or so, I'll be just yeah, I'll be just focused on that. Okay, so I'm just gonna go through this 110 questions. What is supervised learning? Supervised learning is machine learning approach in which an algorithm learns from labeled training data to make predictions or classify new unseen data. It involves the use of input data and corresponding output labels, allowing the algorithm to learn patterns and relationships. The goal is to generalize the learned patterns and accurately predict outputs for new input data based on the learned patterns. So it's basically supervised learning is using data that have already labels and outcomes. The input data has labels and outcomes, and you use that to train the algorithms, train the algorithms. To learn patterns and relationships. And the goal is to generalize learned patterns and accurately predict outputs for new input data with new input data um, with new input data with new input data. Yeah, with new input data based on the learned patterns. Okay. What is unsupervised learning? Unsupervised learning is machine learning approach pray that you allow Alex to figure it out. Just kind of think the game on it though. Help him out. Help him out and I think more than anything. Want them to be teacher. I don't know. Just sense that it's just not cooperative. So supervised learning is a machine learning approach where you have input data that is labeled, training data that is labeled, and you train the models based on that so that in the future you can generalize the patterns for new input data in the future that doesn't have the outcomes. Unsupervised learning and machine learning approach where an algorithm uncovers patterns and structures with unlabeled data. So the difference is labeled versus unlabeled. Operating without explicit guidance or predetermined output labels. So you made the right decision. Mhm. You're laughing. That's interesting. Yeah, because you made the right decision. Unsupervised learning is a machine learning approach wherein an algorithm uncovers patterns and structured within unlabeled data. Okay, so now we're talking about unlabeled data. Previously, we're talking about labeled data. I already know this. Yeah. Subjective is to reveal hidden relationships, patterns, and clusters present in the data. Unlike supervised learning, the algorithm autonomously explores the data to identify inherent structures and draw inferences, proving valuable for exploratory data analysis and discovery of novel insights. So, unlike supervised learning approaches, unsupervised learning approach is good for EDA, exploratory data analysis, where you can um, use it to discover new patterns or um, hidden relationships that may exist in the data. What do you understand about linear regression? Linear regression helps in understanding the linear relationship between the dependent and independent variables. Linear regression is a supervised learning algorithm. Yeah, it is. Which helps in finding the linear relationship between two variables. One is the predictor or the independent variable, and the other is the response or the dependent variable. In linear regression, we try to understand how the dependent variable changes with respect to the independent variable. There's only one. Yeah. So linear regression is trying to determine a linear relationship Linear regression is a supervised learning algorithm where it helps you to learn the linear relationship between variables. You have the independent variables and the dependent variables, and we're trying to determine if they have a linear relationship and what that is, and to what extent that relationship is linear. Um, and there could be one independent variable, or there could be multiple independent variables. What do you understand about logistic regression? Logistic regression is a classified classification algorithm. Yeah, logistic regression is a classification algorithm where the dependent variable is binary. take an example here. We're trying to determine whether it will rain or not based on the temperature and humidity. Right, right. So, yeah, so exactly. So, logistic regression is a classification algorithm where you have classification algorithm where the outcomes are binary. The dependent variable is binary, going from 0 to 1. And yeah, it goes from 0 to 1. Yeah, I think that's it. Where's the confusion matrix? Confusion matrix is a table that is used to estimate the performance of a model. Tabulates the actual values and the predicted values in a 2x2 matrix. True positives. This denotes all of those records where the actual values are true and the predicted values are also true. Right. Performance, yeah, confusion matrix is a table used to estimate the performance of a classification model, and it's a 2x2 table, and you have the actual value and the predicted value, and you have true, false, true, false, and if it's true, true, it's true positive, it's true, and then you have the false negative. Or yeah, true positive and true negative, and then you have the false positives and the false negatives. True positive denotes, so false, yeah, false positives means predicted was true, but then actual is false. False negative is actual is true, but predicted is false. What do you understand about true positive rate and false positive rate? True positive rate in machine learning, Lord, I have so much to study. At least 2 weeks of preparation. In machine learning, true positive rates which are also referred to as sensitivity or recall, are used to measure the percentage of actual positives, which are correctly identified. True positive rates or sensitivity or recall. Man, do I need to memorize this? Are used to measure the percentage of actual positives. Measure the percentage of actual positives, which are correctly identified. So, among all the positives, how many are? Among all the actual positives, how many are? No, among all the predicted positives, how many are true positives? The false negative rate is similar. Probability of falsely rejecting the null hypothesis. False positive rate. Okay. False positive rate is calculated as the ratio between the number of negative events wrongly categorized as positive upon the total number of actual events. So among false positive is among all the true negatives, how many were determined to be false? So you have true positive rate, which is sensitivity or recall, and that is among all the actual positive, among all the predicted positives, how many are true positives? And then false positive rate is among all the negatives, all the actual negatives, how many are predicted to be falsely positive? How is data science different from traditional application program? Data science takes fundamentally different approach to building systems that provide value than traditional application development. In traditional programming paradigms, we use to analyze the input, figure out the expected output, and write code which contains rules. I'm anxious about the meeting with Jason and the other teammates here. I don't know how much I can contribute to the dream. I think Sid should join. Pray that it'll go. Data science takes fundamentally in traditional programming, write code which contains rows and statements needed to provide. Data science shifts this process. Large volumes of data. The mappings to the expected outputs. Then we use data science algorithms, which use mathematical analysis to generate inputs to outputs. This process of rule generation is called training. Okay, so the difference between data science and the other stuff is that data science, there's a process of training the model where the model will learn patterns and recognitions and patterns and relationships that may not be apparent um, upfront. Uh, and using that, you can determine predictions and outcomes and rules that can help us make better decisions. Explain the differences between supervised and unsupervised learning. Supervised and unsupervised learning are two types of machine learning techniques. They both allow us to build models, however, they are used for solving different kinds of problems. Works on data that contains both input and the expected output, the labeled data. That's the biggest one. Works on data that contains no mappings from the input, unlabeled. Used to create models that can be employed to predict or classify things. Used to create models that can be employed. Used to extract meaningful information out of large volumes of data. Commonly used supervised learning, linear regression decision tree. Commonly used unsupervised learning, K-means cluster. So supervised learning, unsupervised learning, the big difference here is that supervised learning will have labeled data, labeled data with the outcomes when you're training the model, whereas the unsupervised will not have the output. It'll be unlabeled data for the outputs. And so for the supervised, because you have all these labeled data for training, you can create models to predict and classify things. Whereas unsupervised learning, a lot of times you use it to help better understand the data, doing EDA, exploratory data analysis to find hidden relationships among variables and patterns. And some examples of supervised learning is linear regression or decision trees. And another, for unsupervised learning, you have K-means clustering. You know, it's the weird thing. I didn't need anything for 22 hours. But more than being hungry, I'm tired. It's not weird. It's not good. What is the difference between long format data and wide format data? Long format data has a column for possible variable types and a column for the values of those variables. How did my friend become a director? I guess if I get to L of L5. Anyways, it's not about that, Lord. Oh, I love this. Long format data has a column for possible variable types and a column for the values of those variables. Each row in the long format represents a one-time point per subject. This data format is most typically used in R analysis and for writing to log files at the end of each experiment. Long format contains values that do repeat in the first column. Use the df.mil to convert the Y form to long form. Y data has a column for each variable. What is long format versus Y format?
Consideration I wanted to talk to you about when it comes to having within subjects or repeated measures factors in your studies. We're currently talking about the study with 3 techniques to find contacts in the smartphone contacts manager. And we have the consideration of the format that the data tables take. Turns out something as seemingly simple as data table format affects the kinds of analyses that most statistical packages can actually do. So you should know the difference. There are long format and wide format data tables, like you see in this example slide here. A long format table means that every row only contains one measure for the subject for a given dependent variable. So we have in the long format table on the left, we have subject as a column. We have the independent variable, might be in our case technique here, but more generally it's say X. Then we have the order variable, which gives us the
Okay, so I think I get it. Long format data is just a table format where a subject, where a subject or unique identity can have multiple rows because each attribute will be added to a different row. Whereas the wide format data is where the subject will only have one row and all the attributes included in that row. So for example, if we're measuring people are subjects, and then you're taking the person's height, weight, body mass index. The long format data will have, person A, height value, and the row number 2. Person A, weight value. Person A, BMI value, right? But then the wide format will have person A all in the same row, the height column value, weight column value, BMI value. That's it. All right, mention some techniques using sampling. What is the main advantage of sampling? Sampling is defined as the process of selecting a sample from a group of people, any particular kind. It is one of the most important factors which decides the accuracy of a research survey result. Mainly, there are 2 types of sampling techniques. probability sampling. It involves random sampling, random selection, which makes every element get a chance to be selected. Probability sampling has various subtypes in it as mentioned below. Simple random sampling, stratified sampling, systematic sampling, cluster sampling. Non-probability sampling follows non-random selection, which means the selection is done based on your ease or any other required criteria. This helps to collect the data easily, following our various types of sampling. So there's two types of samplings. One is, sampling is just way to take a sample or subset of the data to estimate the population metrics. And an aspect of sampling. So there's two types of sampling. One is probability sampling, which is you're taking random selections, and there could be different techniques used for random selections. Random selections, which means, it's just random. So there's simple random sampling, which is you have all the population in the bag, you mix the bag really well, and then take one. Stratified sampling and systematic sampling, cluster sampling, multi-stage. Not sure about those, but simple random. And then there's the non-probability sampling, which is based on convenience. It's a non-random selection based on whatever other criteria other than randomly selecting your samples. And this could be convenience sampling, purposive sampling, quota sampling, etc. I do need to go through each one of these, but I'm kind of short on time. So. What is bias in data science? Bias is a type of error that occurs in, it's a type of error that occurs in data science models because of using an algorithm that is not strong enough to capture the underlying patterns or trends that exist in the data. I'm so hungry. In other words, this error occurs when the data is too complicated for the algorithm to understand. So it ends up building a model that makes simple assumptions. This leads to lower accuracy because of underfitting. Algorithms that can lead to high bias are linear regression, logistic regressions. Something happened. Okay, so basically bias is an error that exists in the model because the model is not strong enough or accurate enough to detect the patterns that exist accurately, exist in the data accurately. It's a lot of times due to underfitting. I mean, basically what happens is the model is not able to detect the patterns accurately because it simplifies the assumptions. Um, it has assumptions that simplify the simplify because the model makes simple assumptions about the data that may not be accurate, and then it underfits the data and it creates a bias. Some algorithms that have high bias are linear regression, logistic regression, etc. Dimensionality. What is dimensionality reduction? Dimensionality reduction is the process of converting a data set with high number of dimensions to a data set with a lower number of dimensions. This is done by dropping some fields or columns from the data set. However, this is not done haphazardly. In the process, the dimensions or fields are dropped only after making sure that the remaining information will still be enough to succinctly describe similar information. Dimensionality reduction is basically just if you have too many columns or fields or data points, independent variables to predict an outcome, you well, it's not about outcomes, I guess. It's just more, dimensionality reduction is you convert a data set with many fields or dimensions into a data set with smaller number of fields. And you want to be able to still describe you want to still be able to succinctly describe the information accurately while when you decide which dimensions to drop. Why is Python used for data cleaning and data science? Data scientists have to clean and transform huge data sets into a form that they can work with. It is important to deal with redundant data for better results by removing nonsensical outliers, malformed records, missing values, inconsistent formatting, etc. Python libraries such as matplotlib extensively used for data cleaning. These libraries are used to load and clean the data and do effective analysis. For instance, you might decide to remove outliers that are beyond a certain standard deviation from the mean of a numerical column. I don't understand this question. But basically, I think it's more, why do you want to clean the data? Because the data has inaccuracies and missing values, malformed records, inconsistent formatting or outliers or redundant data. So you want to clean it all up before you make the predictions or before you use the data to do further analysis. Oh gosh, I'm tired and I'm just, ugh. What are important functions used in data science? What are important functions used? Important functions used in data science are within the realm of data science, various pivotal functions assume critical roles across diverse tasks. Among these, two foundational functions are the cost function and loss function. Cost function is also referred to as the objective function. The cost function holds substantial utility within machine learning algorithms, especially in optimization scenarios. Its purpose is to quantify the disparity between predicted values and actual values. Minimizing the cost function entails optimizing the model's parameters or coefficients, aiming to achieve an optimal solution. Yeah, so the cost function quantifies the difference between the predicted value and the actual value in the data. And you want to minimize the cost function. Loss functions possess significance in supervised learning endeavors. They evaluate the discrepancy or error between predicted values and actual labels. What's the difference between cost function and loss function? All right, I'm gonna get going. Oh man. Hopefully I'll be back later. Goodbye. Thank you, everyone.